9 cents does not turn into $30 by magic. That is the first thing to understand. In May 2026, the average industrial electricity price in the United States was 8.71 cents per kilowatt hour. At the time of writing, Lambda lists an 8-GPU NVIDIA H100 SXM instance at $3.99 per GPU per hour. That puts the full machine at $31.92 an hour. Put those two numbers side by side, and the business looks almost absurd. Cheap electricity goes in, expensive AI compute comes out. But that comparison hides something important. 9 cents is the price of 1 kilowatt hour. $32 is the rental price of an entire 8-GPU system for 1 hour. They are not the same unit, and the difference is not pure profit. A comparable NVIDIA DGX H100 system is rated at up to 10.2 kilowatts. At 8.71 cents per kilowatt hour, the server's maximum electricity cost would be about 89 cents an hour. Then add the data center around it: cooling, power distribution, fans, pumps, and facility losses. Using a simple PUE assumption of 1.4, that total moves to roughly $1.24 an hour. Actual results change with workload, climate, and facility efficiency. But the gap is still remarkable. A little over $1 of facility electricity can support a service sold for more than $30 an hour. So the question is not just, how much does the power cost? The real question is, where does the rest of the money go? And more importantly, who gets to keep it? A cloud customer is not buying electricity. They are buying a finished hour of computation. An airline does not sell jet fuel. It sells a seat that arrives somewhere. In the same way, a GPU cloud does not sell kilowatt hours. It sells access to a machine that is already installed, connected, cooled, secured, monitored, and ready to run code. That difference is the whole business. Before the first customer can start a job, someone has to obtain the GPS. Someone has to build the server, reserve rack space, secure grid capacity, and install the network. The operator also needs storage, software images, cybersecurity, technical support, and a billing system that customers trust. If one of those pieces fails, the customer does not receive a cheaper version of the product. They receive no usable compute at all. A server without power is expensive metal. A server without cooling is expensive metal surrounded by heat. And a server without customers is an expensive machine getting older by the hour. This is why cheap electricity creates an opportunity, but not a business by itself. The power may be local. The customer may be on the other side of the world. Electricity does not need to cross the ocean. The completed computation can travel through fiber. In that sense, a region can turn energy into a digital export, but only if it can add everything between the power line and the paying customer. The most important number in this business is not the electricity price. It is utilization. At $31.92 an hour, one 8-GPU server would generate almost $280,000 a year if every hour were sold. That is the ceiling, not normal life. Maintenance happens, demand changes, customers move jobs, hardware sits idle between contracts, and this calculation is based on Lambda's listed H100 hourly price. At 50% billable utilization, the same machine produces closer to $140,000 in annual revenue. The revenue falls by half, but the building does not become half as expensive. Financing payments do not disappear. Network contracts do not disappear. Staff, security, support, and maintenance still have to be paid. GPU time behaves more like an airline seat than a warehouse product. An empty server hour at 2 in the morning cannot be stored and sold next Tuesday. Once that hour passes, the revenue opportunity is gone. That is where the story changes. A company with slightly more expensive electricity, but a full customer queue can beat a company with cheaper power and empty machines. A cloud platform with strong software, reliable support, and trusted billing may earn more from the same GPU than an unknown operator with a lower price. The machine matters, but keeping the machine busy is where the money gets made. The $30 price also tells us who carries the risk. NVIDIA can earn when the GPUs are sold into the system. The power company earns from the electricity the facility consumes. The data center owner may collect contracted rent, and lenders still expect scheduled payments. The operator stands in the middle. It has to combine all of those costs, keep the machines running, and find enough paying workloads before the hardware loses value. And AI hardware can lose value quickly. A new generation may offer better performance or a lower cost per completed job. Customers then compare the older machine against newer alternatives. The server may still work perfectly, but its rental price can fall while its financing cost stays fixed. This is the part people miss when they see $1 of electricity and $30 of revenue. The gap is not a guaranteed margin. It is the space where hardware costs, depreciation, downtime, customer acquisition, and operational risk all have to be paid. The headline company may have the brand. The company controlling scarce chips may have pricing power. But the operator with strong demand has something just as valuable: the ability to turn installed hardware into billable hours. That is why access to customers can matter as much as access to cheap power. A company can own a warehouse full of GPUs and still lose money if nobody rents them. Just like owning trucks does not create a logistics business when there is no freight to carry. So can a country with low-cost electricity sell AI compute to customers abroad? Yes, in principle. The electricity stays inside the data center. What crosses the border is access to the machine and the result of the computation. But the operator still needs competitive hardware, reliable international connectivity, trusted software, payment channels, data protection, and enough technical support to keep the service running. A cheap megawatt in the wrong location, with weak connectivity or no customer pipeline, is not automatically valuable AI capacity. A press release can promise a new compute center. The operation has to prove that the machines can stay online, complete jobs, and meet service commitments. And scaling makes every weakness larger. 10 servers can sometimes be managed through improvisation. 1,000 servers require standardized maintenance, spare parts, network planning, cooling capacity, and disciplined scheduling. One recurring fault can turn into thousands of lost billable hours. This is why the real product is not the GPU. It is reliable delivery. Cheap electricity is an advantage. Advanced chips are an advantage. A strong customer base is an advantage. But the business only works when all three meet inside the same operating system. The future of AI is sold as intelligence, but it is built as an industrial conversion system. The next race will not be decided only by who buys the best GPUs or who finds the cheapest electricity. It will be decided by who can turn power, hardware, and infrastructure into reliable, billable compute, again and again at industrial scale. Technology tells you what is possible. Industry decides what can actually be delivered. Because compute is not real when the server is installed. It is real when the customer can use it. This is factory logic.